Here come the answers to the chart. I'll just write the answers in first. For those of you that just want to get the down and dirty answer key, this is 90 degrees. 225 is 5 pi over 4. The degree for 2 radians, notice there's no pi symbol right here, so I'm probably going to have something that's a little bit out of the ordinary. This one rounds to approximately 114.6 degrees. And 150 degrees is the same as 5 pi over 6. And I'll save you the down and dirty. If you got those 4 correct, then you clearly know how to convert between decimals and radians. If not, consider going back and trying some of these questions again using the d over 180 equals radians over pi. Just put the correct number or value in the correct location and work on cross products. I'm going to flow right into the next piece because there's no sense having so many different videos. Now let's focus on finding the sine and cosine of a radian measure. And we messed around with finding sines and cosines of degrees, like 30 degrees or 150 degrees in class yesterday and today. I'm recording this on Tuesday after school. So while today we worked on cosine of 120 or we worked on sine of 300, these are 2 examples I recall from class. What we're going to do is we're going to take out the degree and we're going to work on, well, something else. We're going to work on a radian measure, which would look something like this, right? The cosine of pi over 4 radians or the sine of pi over 4 radians. And when you're working on these problems, it's important to know that we're actually going to revert back to what we did yesterday and today. We're going to actually just convert these back into degrees. So since I just did this chart, I'm going to use this a little bit. If pi over 2 is 90 degrees, then half of that, pi over 4, would be half of my degrees, or 45 degrees. So I'm going to go ahead and not really cheat it, but I am going to use that concept of the d over 180 equals radian over pi. If you need that, that's what you would use here. In my purpose, I kind of already know what my cosine of pi over 4 is because of the chart above. So I'm going to go ahead and get rid of this and change it to cosine of 45 degrees. That's going to be step number 1. And once I identify that's the degree, I can go ahead and identify sine of 45 degrees as well. And that once again is step number 1. Step 2 says create a drawing of the angle within the unit circle. This is really what we did in class on Tuesday. A quick little sketch. 45 degrees looks like it's about this. We're going to draw our triangle down. And we're going to go ahead and try to label some angles. Now this is 45. Sorry, it's a little bit small. This is 45, and this is a unit circle. So 1, square root of 2 over 2, and square root of 2 over 2. And then we simply apply. Sorry, let's go back here. So that is step 2. And then step number 3 is going to be use the lengths of your triangle with SOHCAHTOA to find the point, whichever one we're working on. So in our particular case, we're working on cosine of 45. That's going to be, remember, cosine is this one. So we're working on finding that x value of this particular point, and the x value, as you can see, is right here. So I have to do very little work. It's the square root of 2 over 2. And while I'm at it, the other question was the sine of 45. The sine of 45 is simply this value, the up and down value of that same purple or now red point. The up and down value you can see is the square root of 2 over 2 because of this special characteristic of this kind of triangle. So this is your first answer. This is the cosine of pi over 4, and this would be the sine of pi over 4. And that's the concept. It's basically exactly the same thing we did the other day. The only difference is you convert it into degrees in order to work on the problem. Once again, pause the video, try this next question, and then the final video will restart with the answer key and then the final piece.